So let's continue with this problem. Remember, in the last video we computed the derivative and then found its radius of convergence, and it turns out that the radius of f prime is same as the radius of f. Now I already explained how to take derivative of a power series, and note in part C we have to take derivative again. So second derivative of the function is nothing but first derivative of f prime. So here is our expression for f prime, we just have to take the derivative of it. And remember, taking derivative of infinite series is same as taking term by term differentiation of each term and then add them all together. So directly, let's write it down. So let's start with the series, and then we'll be taking derivative of the nth term, n x to the n minus 1 over 3 to the n. And remember, this is derivative with respect to x. N is considered constant. And so, n and 3 to the n will be constant, so you can pull it out. And the derivative of x to the n minus 1, again using power rule, it will be n minus 1 x to the n minus 2. And notice that center for this series is also 0. Okay, now we just have to compute the radius of convergence of this new power series right here. And we apply ratio test as before. Okay, so write down a n, which is just this expression, n minus 1 x to the power n minus 2 over 3 to the n. And then write down the n plus 1th term, looking at this nth term. So wherever there's n, write down n plus 1. So the first, this n will become n plus 1. Then we'll have n plus 1 minus 1, which is just n. Then x to the power n plus 1 minus 2, that is n minus 1, and divided by 3 to the power n plus 1. And now, compute the limit as n approaches to infinity, absolute value of a n plus 1 over a n. And you know, we keep the a n plus 1 term as it is. So n plus 1 n x to the n minus 1 over 3 to the n plus 1. And then the a n term we flip and multiply. That will be 3 to the n over n minus 1 x to the n minus 2. Okay. Let's see if something cancels. Well, look, the like terms, the 3's, they will cancel as before, and the x's will also cancel. What else? Oh, look, there is an n in the numerator and an n in the denominator. So they will cancel as well. The n plus 1 and n minus 1 will not cancel. Okay. So let's write down the simplified form. Let's see what the constant is going to be. Look at the x terms. There are n minus 1 many in the numerator, n minus 2 many in the denominator, which means there is an extra x in the numerator. Okay. And of course, put the absolute value against x. You know that x can have negative values. Now, there is an extra 3 in the denominator because there's n plus 1 and there's n. So, we'll be divided by a 3. And then, we'll be left with n plus 1 over n minus 1. Now, what about this term? Can that be negative? Well, the n plus 1 will not be negative. N is always taking positive values. What about n minus 1? Well, maybe it will be negative for say n equals 0, but we don't care about the first few values of n, right? Because we are only considering the limit as n approaches to infinity, which means n is taking large values, which means we only care about values of n that are greater than 1. So this expression will also be positive. You don't need absolute value against it. Okay. Now, this is a limit on n, so the absolute x over 3 is a constant. So pull it outside the limit. And look, the highest power of n in this expression is 1. So you just divide both numerator and denominator by n, using a similar trick that we have used before. Okay. Inside the limit, now you can, in the numerator, you can cancel. See, n over n will cancel to give you 1, then plus 1 over n. In the denominator, same thing, n over n is 1, and then minus 1 over n. And you know the reason we do this is because as n goes to infinity, this 1 over n will approach to 0. So finally, the limit is absolute x over 3 times 1 over 1, which is just 1. So this is the limit. And ratio test says that limit less than 1 will imply converge. And we have seen it's the exact same limit as in the previous two videos, and absolute x over 3 less than 1. Solution is x lies between -3 and 3. Also note the center is 0 for this new power series. So if you draw the number line, center 0, interval is between -3 to 3. Therefore, radius is the exact same radius as before. Radius is again 3. So for this second derivative, this new power series, the radius of convergence is also 3. Now in the next video, we will finish the problem by computing the antiderivative of the function and then its radius of convergence.